for example, what I was doing was initially I had two sets of documents. Some were fraudulent, some 10Ks, some fraudulent, some were non-fraudulent. And I was just comparing how they use the phrases differently. So here's the most common five-word phrase in fraud documents for the year end, and it's also the most common in non-fraud documents. And I had to scale these so that they were equivalent by the number of words. So my fraud documents had a lot more words than my non-fraud documents, so I had to. So here's the real difference: 1,024 versus 851. So these are on the same scale. So one of my challenges was I wanted to come up with actual, I started with 4-word phrases, but many of them combined to form 5-word phrases and 6-word phrases. And the 6-word phrase is actually the natural phrase size, not the 5 or 4-word phrases that are contained within it. So I ended up combining my 4-word phrases into larger phrases. What's a good strategy for doing that? You guys think of it? So there's a 5-word phrase. There's a 6-word phrase here, right? There's two. It's for the year ended December 31st. That's the actual phrase. But right now it's split into two. So if I want to create a single set of phrases, and I don't care how long each one is, I just want all the natural phrases in the list. How do I eliminate these two and just come up with one phrase? What would your strategy be for doing that?
Similarities or?
Similarity.
Okay, obviously they're very similar. Obviously, they intersect quite a bit. But
First 4 words and last 4 words.
First 4 words. No, I could easily combine these. That's not the question. The question is, which ones do I... What metric do I use to say these two should be eliminated and I should use the 6-word version instead for my list of natural phrases? You know what I mean? Like, I have no problem finding the 6-word version of this. Okay, it's obvious. Maybe
if we look for two that have short words and not the same order.
All right. Let me go to my list of 6-word phrases. All right. So, here it is. Here's my natural phrase for the year ended December 31st. Right? It's a 6-word phrase. What do I know about it? I know it occurs this many times in fraud documents, this many times in non-fraud documents. Okay. Let me do this. Somewhere I have a database of all well, either way, it doesn't matter. So let's go back to where I was. I'll just tell you what I did. So basically, I started with the largest common phrase, like 7-word phrases. And I could say, oh, okay, so this 7-word phrase occurs 1,000 times in my data set. And then I go down and I look at the 2 constituent 6-word phrases in my 7-word phrase. And I said, oh, well, they occur, one of them occurs 1,100 times, and the other one occurs 1,200 times. Well, they must occur together 1,000 times to form that 7-word phrase. You know what I mean? So, if the small phrases occur about the same time as the larger phrase, that means they occur together most of the time. Make sense?
Yeah.
So if they occur together most of the time, then I say, up to some point, I say, okay, well, I'll just assume the common phrase is the larger one, not the smaller one. But I actually worked my way down, starting at the 4-word phrases. So I find 2 4-word phrases that have 3 words in common to make a 5-word phrase. And I check to see if it should be a 5-word phrase instead of a 4-word phrase. And if it should be the 5-word phrase, then I get rid of the 4-word phrases. Then I check the 5-word phrases and see if they occur more often together as a 6-word phrase. And if they do, then I get rid of the 5-word phrase and I keep the 6-word phrase. Okay. So I end up with a list of common phrases.
Did you examine like 4-word phrase and 5-word phrase, or something like where you jump up 2? Like instead of 2 5s that make 6, maybe 2 5s that make 7.
So 2 5s don't really. If 2 5s make a 7, there's an extra word in there. Like a 7 will be made up of 3 5s. Always. Like if you slide 5-word window from the beginning to the end, it starts at 5, it goes 1 through 5, 2 through 6, 3 through 7. So, but I start by comparing the 5s to the 6s, and then the 6s to the 7s. So let me show you the final output, if I can find it, of my I'm going to show you my common phrases. Yeah. This is for all MDNAs, not just fraud and not fraud. This is all MDNAs up to 2016. So these are my largest bundles that I found. They come straight from the title. And
How many take case for this?
like 30 or 40,000. I can't remember. I don't know why I didn't see my database right there. So yeah, I had for the year ended December 31st. For the years ended December 31st. Should be read in conjunction with. These are my common phrases that are 6 words. So I still haven't done anything with this, except to show, oh, these are the most common phrases in the MDNA. So the first thing I did with this is I started categorizing the phrases as different types. So I went through at this point I did a manual process. Let me see if I can find my manual coding. So I manually coded it, and I found one common type of phrase. There's like 20% of the phrases were this type of phrase, and they were just. So I'm trying to write it. I want to know what it was. I was looking at conservative or hedging phrases.
What's the criteria to go upper the word count to minimum and 30,000 to go to more bigger chunk?
Oh, they have to occur. You mean how do I identify the common phrases?
To the
They had to occur
criteria.
at least 5% of the documents, and 30 times per million words. Those were the common. Okay, so anyway, if you're interested in this, I can share with you my code.
Yeah, please.
You are interested?
Yeah.
The nice thing about this class, Dr. Kieran, is that we share our code with each other. So everyone in this class has Ben's code from today, which is really helpful to have Ben's code. But you have to be enrolled in the class. You can't just be like YouTube. So, okay, today we were talking about topic analysis, LDA. So I haven't actually. I have a paper that uses LDA. It's really cool. So let me tell you what we do. I don't have it with me, but let me tell you what we did. We were looking at risks before and after the financial crisis, and we wanted to know if financial crisis related risks increased after the financial crisis. Just one of our simple analyses. To do that, we created.
Disclosure, you mean?
What's that?
That disclosure.
In item 1A, yeah. To do that, we created a dictionary of financial crisis related terms. And to do that dictionary, we used LDA. So what we did is we found 50 Wall Street Journal articles about the financial crisis. So we manually downloaded those. And then we used LDA, and you can set certain parameters. Like we said, we only want one topic. We already know there's only, well, we know the one topic we're interested in. We could use 2 topics and probably get the same result, which we need to do actually. So we set the number of topics to 1, and then we look at the first 25 words and the results of the LDA. So these are the 25 words that are most commonly associated with the one topic that's found in our curated set of Wall Street Journal articles about the financial crisis. And those 25 words had served as our financial crisis dictionary, which we then used on our item 1A and said, do these words occur more before the crisis, after the crisis, during the crisis? Is there a lag where they don't occur? They do occur more, but it's a year later after the crisis, so they weren't predictive of the crisis, they were more reactive. So that was a neat way to use LDA. So I found this, so my student did the LDA, but I found this great website that walks you through an LDA implementation, and it works in Anaconda. So I copied the code, and I got it working in Anaconda. So if you just Google this title right here, you can find the website. But what you'll have to do in Anaconda is install the GenSim package, which is a topic analysis module. So I went and did that. How do you do it? Conda. I did it a different way. Conda install. Is that pip install? Yeah, it didn't work. What I did is I'll show you what I did. Where's my? I went to my Anaconda Navigator and I clicked on environments, and I just found I went to the not installed packages, and I found GenSim, and I installed it. You just click on the one you want, and you install it. And that's what we're. But how does
If you have an exclamation point,
The PI
install, and then Jensen.
exclamation?
Income, you got.
So it probably works the same. So I installed it and I copied all the code from that website. And it's a lot of it's basic cleaning up documents like we've done before. If you go down to if you go to this website, you go down to the bottom, it has all the code in here. Now what they do is they import this thing called, they have this module called stop words, and they import get stop words, and that wasn't installed on my Anaconda. So I used NLTK stop words. So in my code, I commented that line out, and I said from NLT corpus install import stop words, and then where they create the list of stop words, I changed this line right here to that'll be end stop equals set stop words equals, and that uses the stop words from NLTK. So in this example, they give 5 different documents, A, B, C, D, E. Some are about broccoli. My mother spends a lot of time driving my brother around to baseball. Yeah, they're just. They put all the documents in a list, and then they lowercase them. They tokenize them. They take out the stop words. They stem the words. They create a term document matrix, which is like all the documents on the left and all the terms on the top, and the count of the words in each document. And they create this LDA model. So what you can do is you can specify the number of topics, and you can specify like how many times the LDA algorithm goes through the text to generate the model. So this is a very small model. We could increase our passes to 30, 40, 50. And then if you run the code, it already ran, so mine's already out. And you can print like the top 4 words for each topic. So we have drive, increase, tension, expert. That's one topic. Broccoli, good, eat, mother. Health, pressure, school, scene. So this is a very small data set. I wouldn't expect this to work very well. So this is a simple algorithm. I basically just took this code off here and ran it. So now the other topic. Are there any questions about this?
Is there a number of those words? Is that the occurrence of the words?
Yeah. Oh, these are like probabilities that the word occurs in that is associated with that topic. So it's really nice if you can use these when you're. You can use this and multiply it by a word count. So to kind of get a standard, like a more standard, or what's the word I'm thinking of? Like a more standardized count for each topic, I guess. So the word drive might be related to several topics, but it might be more related to one topic than another. But you don't have to remove the count from the other topic completely. You just multiply it by the smaller probability.
So it's just kind of normalization.
Yeah, normalize it. Yeah, you can normalize it by the probability. That's the word I was trying to say.
So the three topics are also ranked in your importance.
I don't know that they're ranked in any way. I don't know.
Read the 5 sentences. I mean, it kind of gives me a sense that like the drive topic is more linear and then the LD probably. So I don't know.
I've never seen that it's ranked. Maybe it is ranked.
Shouldn't the topics have a probability as well of occurring in the entire corpus? So the words should have a probability within the topic, but then the topic should also have a likelihood of occurrence within the entire corpus, right?
I mean, maybe that can be derived by the probabilities in front of the words in each topic.
Because I just thought the word probabilities were subsets of topic. So like should see all those words be like a full 100% at a certain point. All the words that are in the topic are 100%. And then the topic should each have, like if you've got 5 topics, each one should have a probability of occurring and be added together to equal 1. That's my understanding, and maybe this is modeling it a little bit differently or it's smaller, but that was my understanding that the topics get a percentage, a distribution, and then the words within the topics get a distribution. So each step has a distribution of occurrence.
Yeah. Well, this is a well-used method in topical analysis papers, so if you think it's useful, then definitely give it a try. Another method for topic analysis that I know a lot more about because I used it in my paper and I created the method. Uses search engine, leverages the search engines. Okay. So let me open this paper on past and future AIS research. All right. You know, I'm not sure you can download it without a AAA account.
Okay, that's better.
That's fun.
Let me see. Oh, I know where I had it. Tenure packet. Okay. So in this paper, I was trying to find common themes in AIS research, accounting information systems research, over the past 30 years. And this was in an anniversary paper for GIS, the journal. So the journal turns 30. We had a special panel where we talked about the research in AIS. And we were told to write a paper about, past AIS research and what we thought about the future of AIS research. And so I thought, well, I should look at past AIS research, but I don't want to be subjective about it. I want to automatically identify the main themes from past AIS research. And I also didn't want to limit the number of themes. I didn't want to use LDA, and with LDA you set the number of topics, you analyze the words in the topics, and you say, okay, these kind of go together, so this is actually the real number of topics. So I didn't want to constrain myself with any set number of topics. I wanted to be even more exploratory. So what I did was, see if I can zoom in here. Okay, so first I downloaded and I used Yui's help. Yeah, did you help with this too?
Yeah.
Thank you so much, both of you. So they downloaded a lot of the abstracts for me from 3 journals: JIS, IJAIS, and JLab. And we just looked at the abstracts, not the actual content of the articles. And so I took those abstracts and I wanted to identify the major themes. So I actually used part-of-speech tagging first. So I use this definition of a noun phrase right here. You see that? So you recognize these parts of speech? So a noun, any type of noun. So there's NN and NNS. I think those are the 2 types. And maybe NNP is like a proper noun. So any type of noun or adjective. And I guess 0 or 1. And then any type of noun, 1 or more. So you have to have at least 1 noun. Okay. But in front of that noun, you could have more nouns or adjectives. So this 1 noun could be model, but a noun with adjective could be continuous auditing model. See, so the first step was to go through the abstracts and give all the words parts of speech, and then I identified combinations of these parts of speech to identify what I call noun phrases. And this wasn't something I made up. This was I stole from a different paper. So I implemented this, and I found. I said these noun phrases in these abstracts are candidate themes. They could be themes in AIS research. So I found 30,000 candidate themes. That was a lot of themes. So what I did is I then said, well, I only want themes with important words. You know, they're words that are weighted highly using TF-IDF. So I weighted all the words in the abstracts, and then I looked at the themes and the words they contained. And I said, all right, all the themes with, let's rank the themes by importance, by how important the words are in the themes. And I then ranked the themes by importance, and looks like I ended up with, okay, so I was pretty generous. I said, I considered noun phrases important if they contained at least one of the top 12 important words in their abstract. So after finding those important phrases, the total number of themes was 8,000. The total number of distinct themes was, there were some repeats between the abstracts. So the total number of distinct themes got whittled down to 7,375. So the problem was, a lot of these themes had very similar meanings. So here, like continuous auditing was one, continuous reporting environment was another, continuous auditing techniques, continuous assurance model, continuous assurance process. So here are 5 themes that probably should be combined into one theme. And so what's the best way to do that, do you think? Because you could say they all have the word continuous, but that may work, may not. Do you remember what I did? Probably says right there.
The search.
So what I did is I Googled all the themes. But I actually used Bing because Google's not nice. So I Binged all the themes. And I looked at the web pages that were returned by the search results. And I said, all right, let's look at the top 10 search results for each web search. And if continuous assurance model and continuous auditing techniques, if they have any of the same web hit within the first 10, then I'm going to consider them a similar theme. So I combine them into one. So I just look at the intersection of the search results for each theme, and then I combine them that way. Now there are billions of web pages. So if you share one top hit in the top 10 with another theme, I figure they must be similar enough. Maybe I should have done top 20, but I ended up combining my themes such that the 7,300 became 4,400. Most of those, about half of them were singleton. They only occurred once in the 700 abstracts. Most of them. But if you look at the results, here we go. 3,000 of them occurred once. 560 occurred twice. 231 occurred 3 times. So one of them occurred 63 times. One of them occurred 58 times. These are common topics in AIS research. So we can look at what they were. So the top theme was not very meaningful, maybe?
Is it general?
What's that?
Is it the general?
Yeah, it's very generic. Yeah. Accounting and AIS research. The second theme, different internal audit organizations. The cool thing about this is it was completely automated, right? I could have changed the themes so they kind of made more sense. Information system development was number 3, the top. So what these graphs show is starting in 1986, the raw number of theme occurrences. The middle line is the year 2000, and the last line is the year 2014. So I just charted them. And because these are all relative to their own data, like the height of the peak. So this high peak is only 6. So the highest peak here is 8. Highest peak here is 8. And some of these topics you can see coming and going. So internal control seems to be spiking as of late. ERP systems were very flat, and then research started. That makes sense. XBRL didn't start until 2001. This is a typo. This should not be a 1 here. Continuous auditing techniques. Where's the REA? Oh, there's REA. So I just kind of talked about what the top themes were.
So do you think your method is more effective than LDA? I think intuitively it's more like makes more sense?
I think it depends. I mean, I don't know what I would have gotten with LDA except words that group together, and then I would have had to name the theme something.
Right.
And in this way, I didn't pick any of the names. I just used the one that. So when I group themes together based on the web hits, maybe there's sort of a chain. Like continuous auditing technique would be related to 10 other names, but the ones on the fringe, maybe continuous reporting environment, were related to one or two of those.
Okay.
So the one that was related to the most is how I picked the name for the topic. So yeah, I don't know if it's different than LDA. So Yui and I, we were trying to do something similar, right, with risk factors, and come up with different types of risk factors in a different way than what was done in the other papers. So the Campbell paper, they just decided, oh, there are 5 risk factors, very broad, and here are the key word lists that we use. The Bow and Data paper said, oh, we're going to use LDA, and based on our measurements and things, 30 topics is the right number of topics. 31, we get less, we get a little bit worse results or whatever. So there were 30 topics. So what I was saying to Yui is we should come up with risk factors that, what if there are risk factors that don't group well with another topic, right? In the bound data approach, every risk factor, you might say, gets put into one of these 30 topics. But there might be some strange ones that are new risk factors and don't relate, it's a new topic, and they need to be identified. So that was kind of our idea was we shouldn't limit the number of topics, but we kind of got lost in all the mess of what we were doing. So we ended up focusing on one type of risk factor, and we're working on that paper now. Credit risks. Okay. But we're going to get back to it someday. Okay. I don't know what type of assignment I should give based on this, except I think you should use LDA because it's easy. Yeah.
Just to add a interesting fact for LDA. So if you think you run an LDA with number of topics 100 and you run that on the entire Wikipedia, which topic would you guess that has the highest?
You mean
Wikipedia dump. So
yeah.
You mean if you run 100?
But the topic is represented by the words in
yes.
the topic. So
well, I know that also because I was doing one.
Did you do this yourself?
Yeah, but it's following others' code.
Oh, okay.
So actually, the result is that the book and novel they have 25%.
Books and novels.
Yes. And
what if you run it on the whole internet?
Wikipedia dump already has, almost hundreds of gigabytes.
So here's another interesting fact. So my buddy who used to be at Princeton, he was gonna sit on some panel about a journal and its past research, and I said, "Hey, I know exactly what you should do. You should do this topic analysis like I did in mine." Except he didn't use Bing. He used the Wikipedia search engine because Wikipedia has how many articles in it? Like millions, right? 100 million articles.
I'm not sure.
So what you can do, another way to find words that you could say that belong to the same topic. You could say each Wikipedia article is one topic. And so if I'm searching, if I use the search engine, which is easy to do in Python, if you do a Wikipedia search and you find a topic, then whatever the terms are that you put in, they belong to the result, the top article So what he did is he took all these terms from the abstracts of this journal, and he did Wikipedia searches, and he said, he did some sort of word map, those words that crisscross with each other. There was one in the Bowen data paper, word clouds, yeah. So he did a word cloud of the Wikipedia articles that were generated from the search terms that came from the abstracts of the journals. He said it got, people like. All right, so the assignment. Don't want you to just use LDA on your MDAs. What I want you to do is use at least 10 companies from 2 different industries, and just do an LDA analysis of the MD&A or the risk factor section. Just pick two different industries.
2 different industries.
Yeah. So you haven't extracted risk factors yet from the 10K, so I won't make you do that. But use the MD&A and play with LDA and set the number of topics to 1, 2, 3, whatever, 20, I don't know, and try to find the number of topics in an MD&A in your data set, and do it for the 2 industries, and see if you can come up with industry-specific topics that would discriminate between the 2. Okay, and use the LDA code. You can use the LDA code on.
So we do it in 2 different industries, and then we compare the 2 industries.
You do a qualitative comparison of your results.
Oh.
You say, here are the topics I found for this industry. Here are the topics I found for this industry.
Okay, so 10
and you can give them names like people do. They say, oh, this topic has this, the word boat, barge, port. This is the shipping topic, boat shipping by boat topic, Using TF-IDF to do what?
Stuff with the keywords, vectors,
do a cosine similarity. In conjunction with the LDA? Or is it separate?
We have the vectors for the keywords, right?
Yeah, but the keywords are already weighted also, which based on like the probability that they belong to each topic. I think that kind of, I don't know, that might give an importance weighting for each topic. For each. You know what? You do the TFI. Show me what you did, and I think it's a good idea. So now you have to. So at least 10 companies in the same year. Each 10 companies, so 20 companies total. Everything should be in the same year, and I want to see if there's any industry-specific topics you can find using LDA.
I think there's an interesting website called Wordle.net. So you
Wordle?
can use, yes.
Oh, to create word clouds?
Yes, you can use that as a way to visualize your result.
Yeah, if you want, you can create word clouds.
How do we spell it?
WORDLE. Wordle.net.
So Yan is requiring this of you.
No, I'm not requiring that. I just say you have a tool to a toy to play with.
Yeah,
no,
word
you don't
clouds
need.
is fun. All right.
Same 2 different.
Any questions? I guess we finished a little bit.